Okay. Hello, everyone. We are live everywhere, so this is a great time to start. First off, I would like to welcome everyone to our workshop number 14. So, what is this workshop all about? This workshop is going to be all about account abstraction in practice with our amazing speaker, Darlington, here. Darlington is a blockchain developer passionate about leveraging cutting edge technology to build secure and decentralized solutions. With a deep understanding of blockchain fundamentals and expertise in both Ethereum and Starknet protocols, I have to say this at this point that I started learning Starknet through Darlington's Medium articles. There was a series of Medium articles that he wrote, and I really found them super intriguing. And of course, he
Thank you so
specializes in
much.
developing. He specializes in developing smart contracts and exploring innovative use cases within the blockchain ecosystem. Currently, he is the ecosystem associate at Argent, a contributor at Starknet Africa, and the dev lead at a university blockchain club in Nigeria, Blockchain UNM. Welcome, Darlington. We are super excited to have you. And I think it's been a while since we have done a workshop, and we are really excited to. Account abstraction has become such a spoken about topic. Everyone is talking about account abstraction. How can account abstraction be the next big feature in the overall Web3 ecosystem to onboard billion users? Right? We always say that the user experience in Web3 has like miles to go. But can account abstraction be that key to success? Maybe, maybe not. A lot of hype around this topic, so let's get to know from Darlington about account abstraction. So maybe Darlington, if you could just start us off with what is account abstraction, and of course, walk us through a little bit about how protocols like Starknet implement account abstraction right at the protocol level and not just at the application level. And yeah, stage is yours. Go ahead, please feel free to share any slides that you have and speak to our audience, get them introduced to this topic, and then we'll get started with the hands on.
All right. Thank you so much, Kian. Good day, everyone. I'm so excited to be here. So, shortly before we begin, right, I'm just going to try to share some slides. Okay. All right.
Have you been able to find the present button that's below in the.
Yes. Sorry. This.
Yeah.
Yeah, I've seen the present button. I'm just trying to share the screen. This is actually my first time
Okay.
using
No
StreamYard,
problem.
so things are a bit trying.
Of course, we
Sorry,
understand.
minutes. Yeah.
Yeah, there's an option called share screen. That's probably the
Okay.
easiest way to present because the other options are. Okay, I see your slides.
Okay. All
And here you
right.
go. Hey.
Okay, yeah, so thanks so much. Sorry for that brief delay. All right, so just like Jan said, right, today we're going to be looking at the concept of account abstraction. And it's actually supposed to be a hands-on session, right? Practical session. So we're just going to take a few minutes, first of all, to understand the concept of account abstraction, right? Probably take a look at the history of account abstraction, and then we could probably dive into codes, right? So just a brief introduction about myself, right? Darlington, currently the ecosystem associate at Argent, right? You could catch me up on Twitter at 0x Darlington and on Telegram at Darlington68. So this is what we're going to be looking at today, right? We're going to be looking at an introduction to account abstraction, the history of account abstraction. We're going to be taking a look at the ERC437 standard. Then we're going to look at native account abstraction on Starknet. And finally, we're going to go into writing codes, right? Implementing simple account models such as an account, a multi-call, and a multi-sig on Starknet. Finally, we're going to look at some basic EE use cases like what we do at Argent, basically. So let's just get started, right? Because of time. So what is account abstraction? So account abstraction basically is this buzzword that has been going on for a very long time for recently, right? So we consider it a new paradigm in blockchains because it aims at making accounts programmable, right? So with the concept of account abstraction, every account is a smart contract that can basically contain logic, and as such, it opens us to new possibilities such as social recovery, fraud monitoring, multi-calls, and so on. So before we understand why account abstraction is important, right, we need to take a look at the status quo, how um, accounts are implemented currently on Ethereum. So basically, on Ethereum currently we have contract accounts and externally owned accounts, right? So basically, contract accounts are normal smart contract code, while externally owned accounts are usually where transactions are initiated from, right? So currently, for anything to happen on chain, a transaction must have to be initiated and paid for by an externally owned account. This externally owned account is controlled through a private key. So you know the popular mantra, right? Not your keys, not your coins. So basically, an externally owned account is controlled from a private key. So whoever owns that private key automatically is the owner of that externally owned account, right? So basically, use this private key to create a signature that proves to the blockchain that the transaction you are trying to initiate, right, it's from your own account, like you're a legitimate owner of the account. So basically, this is how externally owned accounts, this is how transactions work with externally owned accounts, right? So you initiate a transaction and you sign the transaction with a private key. So Ethereum currently uses the elliptic curve digital signature algorithm. So you generate a signature, and if that signature is valid, right, that transaction is added to the mempool before it is finally added to the block by validator, right? So, but basically, like I said earlier, there's a lot of pitfalls with the Ethereum owned, sorry, the Ethereum implementation of accounts, right? That's having an externally owned account and having a contract account. So basically, the whole idea of account abstraction, right, is to simplify the user experience for users. Basically, introduce a way better experience than what we have with Ethereum owned account, externally owned accounts, right? So basically, with account abstraction, we have a lot of new possibilities being opened up, right? So there's the concept of social recovery. I could remember that was as at I got into crypto space at 2020, right? And just a few months later after getting into crypto space, I lost my first I think I lost money from hacks, right? And the second time I actually lost my life savings was like 2021, right? And that was because I got my phone stolen and I couldn't recover my wallet, right? Because um, I thought I could cram my seed freeze because I was scared of writing it down in paper and probably keeping it somewhere at home and probably someone having indirect access to it. So I said probably I'll cram it. But then it's not like I guess not all of us are very smart, right? To cram 12 seed phrases, very long to cram, right? So I forgot it and that was how I lost everything I had in that wallet. But account abstraction aims to make these things better, right? For example, with the concept of social recovery, one of those days when losing your keys equates losing your savings. For example, at Argent, we have the concept of guardians. So in a case where you let's say lose your keys, right, you have this certain guardians who could help you recover your wallet back. So losing your keys automatically does not equate to losing your savings. There's also the possibility of multi-calls. So a lot of us have probably interacted with let's say Uniswap and other EMMs, right? And there's this very annoying thing of having to always probably approve before you carry out transactions. But with multi-calls, that becomes multi-call can help improve this, right? Because you could aggregate multiple calls into one. So rather than approve before carrying out the transaction, right, you could aggregate the two calls into one call. And this can only be possible, right, with account abstraction. So account abstraction, like I said earlier, it makes user experience better. Basically, for example, at Argent, we implement something called fraud monitoring, which helps you inspect every transaction to make sure it complies to different security rules, thereby helping you reduce scams and hacks, right? There's also the ideas of session keys, which helps in general improve the current gaming user experience. We're going to be looking at some of these use cases right towards the end of the workshop. So let's just take a brief look at the history of account abstraction, right? So basically, while account abstraction has been making a lot of waves at the moment, right? It has been a long time dream of many Ethereum developers. So it's not just a concept that originated recently, right? Let's take a look at different proposals that have been made over the years that led to what we have today, right? So I think the first proposal was EIP86, which was proposed in 2016 by Vitaly Buterin. I think that was a year after Ethereum was founded, right? So the whole idea of EIP86, right, was to abstract the nonsense signature model of from Ethereum, right? So basically, DApp developers and users on Ethereum could basically use any custom signature scheme and nonce model on Ethereum, right? But the problem with this proposal, I think, was the fact that it required changes to the consensus layer, so it was not the alternative we were looking for. Then I think we had 2938 in, should I say 20? I think in 2020 we had 2938 proposed. So 293 aimed to introduce a new type of transaction, right? So this new transaction was basically supposed to have three fields. I think that's a nonce, a target, and a data. So, but while 293 it's should I say closely in the way models the current 437, it does not eliminate externally owned account completely, right? And they also had a lot of shortfalls. For example, you couldn't implement some of the use cases that make account abstraction as interesting as it is today, right? For example, you could not implement meta transactions with 293 and so many more, right? So there was 3074 proposed, I think that was still in 2020, which aimed to basically make externally owned accounts function like delegate calls, right, from externally owned accounts to smart contracts. And I think that was supposed to be done by introducing two opcodes. That was the auth opcode and the auth call, right? So basically, it wants to delegate calls from standard-owned accounts to smart contracts. But this, like, yeah, 86, right, required changes to the consensus layer, and so it was not I wouldn't say it was the alternative we're looking for, right? So finally, I think in 2021, ERC, yeah, before 337 was proposed, right? And I think yeah, before 337 was a very was the best alternative because firstly, it had the advantage of not requiring changes to the consensus layer. So basically introduced a high level new transaction, right? Which was called user ops, right? User operations. So we're going to, in the next few slides, right, we're going to look at ERC4337 and basically how it works. So the ERC4337 standard. So before ERC4337, right, there were still smart contracts, smart accounts on Ethereum. So, but this is how they worked basically. So you had relayers, centralized relayers, which took transactions which was processed on smart accounts, and basically this centralized relayers was responsible for adding these transactions to the mempool, right? So, but with ERC4337 came in and did a lot of things. For example, decentralizing the relayer. So as you can see here, we no longer have a centralized relayer basically, but this is how the ERC4337 works in a high level sense, right? So every account that implements ERC4337 must have this user up. So the user up is like a high level type of transaction, right? And when the user signs the user up, basically it gets added to what we call an alternative mempool. So this alternative mempool was not the normal Ethereum mempool, right? It's just like I said, an alternative mempool for just user ops, right? When I say user ops, I mean the special transaction that was created for ERC4337. Now, these alternative mempools can be picked up by what we call bundler. So, the bundler, unlike the Relia, was decentralized, right? And basically, what bundlers do is they carry these user ops and they bundle them into a single transaction and then pass it to an entry point smart contract. So, this entry point smart contract is like a singleton generalized smart contract that basically processes bundle transactions and finally adds it to the main pool. And if valid, the transaction can be added to the block. So basically ERC437, amongst every advantages it came with, right, it helped decentralize the layer. So as you can see here, we no longer had need for this was before ERC437, right? We had the layer which added things in the mempool before the node validator processes the transaction. But ERC437 introduced the second transaction flow. So basically, if you have an externally owned account, remember on Ethereum I said we still have EOAs. So the introduction of smart accounts basically did not basically make EOAs invalid, right? There are still a lot of EOAs. We have MetaMask and the rest, right? So basically, this is how EOAs work, right? So when you initiate a transaction from an EOA, like as you can see, it goes into the mempool and validated by a node or a validator right before it's added to the block. But with ERS4337, as you can see, it starts from a smart account, right? The smart account creates a user which is added to the alternative mempool, and then picked up by a bundler. The bundler bundles the transaction, sends it to an entry point smart contract, which is picked up by a node or validator from the mempool, and finally, before it is added to the block, right? So although we could see that smart accounts on Ethereum has gone a long way in improving the user experience on, should I say, on Ethereum, right? But account abstraction adoption on Ethereum still remains quite challenging. It still remains quite challenging and very complicated to implement. So how can we? So the question is, what if we take um, the ERC437 one step further, right? Probably to unlock the full potential of AA. How about we build on, let's see, is generally roll up like Starknet, right? So basically, first of all, we have the advantage of building on zero roll up, which automatically helps us build scalable dApps, right? Then we have, sorry, then we have an integration at the protocol layer. So basically, because we are building after the VM has been built, right? After Ethereum has been built, right? We have seen the pitfalls of implementing what Ethereum implemented. So we could go for that to do it better, right? That implement um, smart contracts, sorry, smart contract accounts, yeah, basically on the protocol level. So there are no compromise, there are no centralized layers, there are no off protocol bundlers. These automatically smart accounts become first class citizens. So we just have a single mempool and we have a simple transaction flow. So there's no need for all the complications like well core cotton joints that we had on Ethereum, right? So that brings us to native account abstraction on Starknet. So basically, on Starknet, account abstraction is it's inbuilt, right? Account abstraction is native to Starknet. So Starknet basically maintains a model where accounts are represented by contracts. So, but with a more defined structure, basically. So, accounts of abstraction on Starknet is still modeled after the ERC437 standard we took a look at. So basically, all accounts on Starknet, right, are expected to implement two major functions, as the validate function and the execute function. So this ensures that the sequencer is effectively able to validate a transaction and get paid for it with minimal risk, right? So I think in the next slide we would I don't know if this is visible enough, right? So um, but this shows how basically account abstraction, the flow of account abstraction on Starknet, right? I don't get, is this very visible? Can you see this?
I can, but it is very
Yeah.
small. I tried to make this big, but maybe if you could just, like, for example, if you want to explain this, then I think you can just go like component by component. Like there is one at the top left, and then there is like a big chunk in the center or something like that. You can zoom in a bit.
Okay. Yeah, sure. Okay. Try and see if I could. I don't think I can zoom this, but I'll just try my best to explain it. So
Okay.
basically, yeah, right. Yeah, so basically, like I said earlier, in abstracted accounts, right? Account abstraction on Starknet, sorry, an implementation of account abstraction on Starknet, right, is expected to have two methods. That's the execute method and the validate method. So to have a high level view of it, right? Just like we see in this picture, right? So when a transaction is initiated by um, a smart account on Starknet, right? The transaction is expected to be validated, right? And if the transaction is valid, if it is valid, right, the transaction pays, the account is expected to pay gas fees for the transaction. But if it is invalid, it is basically the transaction is basically rejected. So basically, every valid transaction, right, whether the transaction is reverted, once the transaction is a valid transaction, it's expected to pay gas fees, right, to the sequencer. So basically, if the transaction is valid and it pays gas fees, then it passes through the execute function, right? Execute function basically is that single entry point that is responsible for executing those transactions, as we'll see when we get into building the when we get into practicalization, right, as implementing our smart contract. So basically, if the transaction, when it gets to the execution stage, right, it checks if the execution is successful. So if the execution is successful, the transaction and its output, right, is added to a batch. But if no, the transaction failure is still added to the batch too, right? So it's expected with Sierra, right? Few transactions are to be proven. So basically, what the sequencer does is the sequencer, the sequencers, I think on the sequencer's own part, right? The sequencer first validates the nonce of the transaction, checks if the nonce is valid, right? And if the nonce is invalid, the transaction is rejected, or if the nonce is valid, right? It simulates the I think it simulates the validates function, right? And the simulation is expected to check that that the transaction basically just assesses the required state it is meant to assess, right, and does not call any forbidden system calls, right? So basically, if the transaction simulation, that's if it's valid, right, then um, the transaction is added to the batch, which after the batch gets filled up, it is sent for proving, right? So I'm just going to probably later on. I'm going to. I don't know if we saw this clearly, Sha, but I'm going to share the slides later on, and we could probably take a look at it and probably ask questions if there are any. So we're just going to move on to building, right? Since that's the main focus of the call, and we are going to be looking at three major types of accounts. We're going to be looking at implement. We're going to first implement a simple account. So basically, a simple account just contains just the validate and the execute function. We're going to implement that. Then we're going to be looking at implementing a multi-call account. So the multi-call example is it's basically we're going to be building an account that has multi-call capabilities, right? So it has the capabilities to batch calls like um, batch multiple get multiple calls into one, right? And finally, we're going to be working on a multi-sig um, account implementation, basically. So a multi-sig, as we all know, is basically a wallet that requires more than one signature to execute the transaction. And I added links to the codes in the slide, right? So you could probably check that out later. All right, so just okay, let's proceed. Let's just okay, sorry. I think I'm going to share my screen. Let me figure out how I'll do that.
Yeah, sure.
Okay, yep, okay. Um,
So, Darlington, like, would people need any setup right now to do this workshop live with you? Or is this something that where you are going to do a code walkthrough and people can try, with the setup and things later?
yeah, so basically we are going to do a hands-on session on a simple account. And because we just have less than 30 minutes remaining, we'll probably do a code walkthrough for the multi-call and the multi-sig. But basically, anyone who wants to follow through can just we just need to install Scarb. I think Scarb would be all you just install and set up Scarb, and you'll be able to follow suit, right? Yeah.
Sure.
So sorry to share my screen. To I want to share my screen now. Do I need to stop sharing the slides in order to do that?
Yes, that's how. So meanwhile, I can just remove your screen share
Okay.
from the stream, and you can stop sharing this and share the other one, and I'll add it back.
All right.
For those of you who are going to do this workshop right now, like live and hands on, if you want to set up Scarb, let me share the link with you, and you can just get that going. See.
Yeah, I think I'm trying to share my screen now. Could you probably add it to
Yeah, I can add it to
broadcast?
this. Oh, let's see. Is it
Okay.
this one?
Yeah, I think that's it. Okay. Um,
Okay.
okay, but you can see my screen now, right?
Yes. Do you have a folder open with like a bunch of other
Yeah,
folders?
yeah, 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 exactly.
Perfect.
Right.
Yeah, you can see it.
So let's just create a new folder. Let's call this account workshop. Right. So I'm just going to open this in my terminal.
Sure. I'm going to get
Okay.
started.
All right, and I'm just going to initialize a new Scarb project. So basically, for those new to Scarb, right, you could just head over to okay, you could head over to I think the Scarb docs is yeah, docs.swmansion.com, right? And you could find whatever version is compatible with your system for installation here. And for the documentation, I think Scarb has a pretty good documentation. So you could just check out the Scarb documentation, right, for whatever command. So for example, creating a new package, working on an existing package, right? So we're not going to walk through the process of installing Scarb since that's not what the workshop is directed towards, but it shouldn't take you a lot of time to do this. It's actually very simple to do. So we're going to start with implementing a new, creating new Scarb project, right? So I'm going to call this, let's just call this Scarb new account, right? And I'm going to move into the account package, right? I'm going to open this in my VS Code, right? It's hanging a bit. Mhm. All right. Sorry, my system is pretty slow. I haven't shut it down in a very long while. All right. So we're just going to create a new file here, and we're going to call this. Let's call this account.carry, right? And okay. So coming to the lib, I'm just going to remove all this. All right. Let's just add the account module here, right? All right. So to get started, right, implementing our account contract, we're going to need to import some methods of the from the core library, right? That would probably need to use. I think we would need to use start with this, right? Okay. Then we're going to need the contract address type. We're going to need their retreats. Sorry. Right.
Can you tell a little bit about the surge package for those of them who might not be familiar with um, serializing and deserializing data?
Okay, so basically, from my understanding of what the serializing and deserializing does, right, it basically changes because we're going to be using it for our custom structs, right? It can help you serialize your your structs, right? Your custom data type, your custom struct into an array, serialize it back into the struct, right? Because I without this, we're going to be running into some errors with the compiler, right? You could just check more that I think the call lib. Okay. So if you head into So this is exactly where we are importing our methods from, right? The Cairo colleague, right? So just head into there and you'd definitely find a lot of helpful um, libraries methods that you could probably use. So, for example, the serialize is we are importing the treats right from this particular file. And like I said earlier, I think the serialize would help you serialize a custom data type, right? Like for example, struct into an array. The serialize does just the exact opposite. So we also get to import the contract address type, right? The contract address. This contract address enables us use have access to the contract address data type, right? Then we import the array treat. So the array treat is imported from the array file. You can see the array file here. And importing the array treat would give us access to these methods contained in the streets, right? Such as the append, the pop front, the get, the outlets, and many more, right? So first of all, we're going to create a custom structure, right? Called call. And the two is going to be of type contract address because it's going to be an address. Then we're going to have the selector, which should point to the function which we want to call in the target contract address, right? This is going to be of type field 252. And we're going to have a call data. So the call data is going to be an array of fields, right? Array of fields 252. All right. So we're just going to derive some treats for our custom structure, right? So we're going to derive the serialize, and we're going to derive the true up treats, right? So next up, we're going to start with creating our account contract. So as you probably know, for if you're working on a normal contract, right, you would use the contract macro. For an account contract, basically, we normally use the account contract macro. So we're going to call this account contract, right? And we're going to specify in module, right? Let's call this module account, right? And inside here, we're still going to import some things. We'll still be using this module, like we're going to be needing the contract address data type. Sorry, we're going to be using the get call address, the get call address method. All right, so we're going to be using I think the get transaction info method. We're going to be using the what else do I think we're going to be using here? The call contract syscall. And I can't say, okay, we're going to need the array treat also. Sorry, array treats. We're still going to be needing the span treat too. All right, the span treat. And we're going to serialize, right? We're going to need the array serialize. Can't think of anything for now. Okay, we would need to import our call since it's outside our module, right? So using the super, we're going to import our call struct. Then we are going to go forward, first of all, to defining our storage variables. And in our storage variable, we want to basically just store the public key of this account. So this is going to be field 252, right? And so first, the first thing we're going to be working on is our constructor, right? So basically, constructor is a function which is called and used to initialize certain storage variables, right, on deployment. So this is going to be the constructor basically is going to take a public key argument, right? And we are going to initialize this public key, which is in the story. That's the public key for the account on the account deployment. So basically, we are just going to call the public key. We'll call the read method on the public, sorry, the write method on the public key, and we're going to pass in our public key, right? So let's just simply return. And next up, we are going to be needing our first external function. Okay, um, I'll just use this. Sorry about that. Now it's using all these autocompletes. Okay, yeah. So this function we're going to call it's the validate declare. So the validates declare function basically, okay, is going to take in the class hash of our account, right, which is of type file 252, and going to return valid if valid, and it's going to return an error otherwise. So basically, this validate declare validates your account declaration, right? So we are going to let's just pass this the logic for this validate declare into an internal function, validate transaction, since we are going to be calling this function in multiple places, right? So I'm just going to come down, right, and I'm going to um, I'm going to implement the validate transaction function. Now, the validate transaction function basically is going to validate the signature of our account, right? So the first thing we probably want to do is let's just get our public key stored somewhere. So let's call this let's use this instead. Public key, right? And the public key is going to be called to public key read, right? And we're going to get our transaction info by calling the get transaction info method, right? And I think this returns a box trade, so we're going to need to unbox it. And to have access to this method, right, we probably have to import from box. We're going to need to import the box trade. All right. So what else do we need to do? Okay, let's get our signature. Let's get our signature. So we could get it from transaction info.signature, right? And we want to check that the signature length is valid, right? It contains both the R and S component. So we're going to assert that signature.length, right? We're going to assert that signature.length is equal to 2, contains the components. If not, we're going to throw an error that says invalid signature. Invalid signature. Okay, then next up we are going to validate the signature, right? So we're going to import from exa. We are going to be importing I think this is called check exa signature, and just confirm. So going to the core lib and into the source folder, yeah, from the exa file, we are going to, yeah, the check exa signature, right? So we're going to be importing the check ETSA signature. Okay. And basically we're going to call that method, and we're going to it takes in some certain things. So the first thing it takes in is a message hash, and it takes in a public key, and it takes in the array component of the signature and the S component of the signature. So we are going to come in here, and for the message hash, we're simply going to query the transaction info for each transaction hash, and for the public key, we'll simply get use the public key we got earlier, right, as the public key of the account. We are going to need signature R, right? Now for signature R, we're going to need to desnap. I'm going to explain why we are using the asterisk sign. So basically, we want to get the fourth element as zeros U32, right, at zero index. So the reason why we are using the desnap function, right, is if I remember correctly, signature is a span element. Basically span is a snapshot of an array. So basically in order to get the element, the signature 0 u32, that's for signature R, right, we need to desnap the elements we would get out of it, right? Since it's a snapshot, we need to snap it in order to get the main signature, right? So for signature S, we would also need to snap the elements at position 1, and I think that would be about it. So I want to check this, and if it is not valid, right, we want to return invalid signature. Just to differentiate both error. Let's call this invalid signature length. Since the length is basically what we're checking. So in here we're just going to return an invalid signature. All right. And so in the case of the transaction being valid, right, we want to return validated. So I think that we need to import that here. So just use Starknet validated. All right. And if you check out what the validated returns, right? Let's go into, I think that should be in here, somewhere down here. So basically the validated is a constant which returns a field 252. That's a short string valid, right? So basically we want to return the short string validated if our transaction is valid, the short string valid, right? And that means we need to return our validate transaction function. We need to return a failed 252. All right. Then okay, we are now going to, I think that works. Yeah. So we're now going to move further to implementing just use this. Yep. We're going
So
to
that
implement.
uh,
Okay.
sorry to
Yeah.
interrupt you. What I wanted to maybe shed some light on is before we move to the next function, could you just shed some light on what is the use case of this contract? Like, what does an account contract do? What does a simple account contract do? And what is the structure? For example, when we create an account contract, what are we doing? And these different functions that you're writing, what are these functions supposed to do as part of the account contract? So if you can quickly shed some light on that.
All right, sure. So no problem. So basically, like we explained earlier, right, we are implementing a very simple version of an abstracted account on Starknet, right? So basically, this account is supposed to. I don't have an interface implemented, right? So, but basically, this account is supposed to have two major functions, like we explained earlier, right? An account implemented on Starknet is expected to have two major functions. That's the validate function and the execute function. So basically, the validate function checks that the signature is valid, right? That the transaction was originated from the account by the account owner, right? So basically, the validate function checks the account checks the signature, right? And if it is valid, the account is expected to pay gas fees. Expected to pay gas fees for the transaction. So after the account pays gas fees for the transaction, it goes further to an execute function, which we are going to be implementing later. So what the execute function does basically, the execute function is the entry point that executes the transaction, right? So it calls the target contract, it calls the two okay, the two function I okay, let me just, so what I'm going to do, right, to make things easier to explain is I'm just going to write I'm going to write the function bodies out, right, without the the logic inside, in to make it look more like an interface, right? So that we could basically explain what the functions do before we move on to implementing the logic. Would that be okay, Gian?
Yes, that would be perfect. And
Okay.
for those of you
Yes.
who are trying to understand terminologies like declare, and if you're new to Cairo contracts,
Right.
then just the workflow for Cairo contracts is that you have to first declare a contract, and that gives you something called as a class hash. So every contract before you deploy, you'll have to declare it because that is something like, telling the blockchain that this is the contract that I'm going to, this is the class hash that I'm going to deploy. That's why you see a function called validate declare. That means when you declare, you use an account that you will use to declare that contract, right? So you need that account to actually verify, validate whether that particular declare is correct or not. So that's why you can see that validate declare. And then all the other different transactions that you mentioned, there's validate transaction, there's execute, which is executing the transaction, and things like that. So just to give you an understanding of how Cairo contracts work, first you have to declare the contract, you will get a class hash, then you have to use that class hash to deploy the contract. Yeah, please go ahead, Danny. This is good.
Right. So I'm just writing out the function body, right, without the go ahead to implement the logic. So this takes in the contract address, entry point, the call data, basically, which is going to be an array of fields 252. All right. Then last function we're going to be implementing, right, is we're going to be implementing the execute entry point, and the execute is, I think, going to just, we're just going to pass in, let's clear this. For this, we're going to pass in the call. It's going to be an um, array of sorry, of call. 2 minutes, and it's going to return a span of yeah, span. So, I think. All right. So basically, these are the four major functions we are going to be implementing, right? The first is the validate declare, which I explained earlier. Validate this function, I think, is called on when you're trying to deploy the account, right? This one validates the declare function for your account. Then we have the validate deploy, which validates the deploy function for your when you are deploying your accounts, right? Then the two major functions I want us to concentrate on, right, are the validate and the execute function. So, like I explained earlier, the validate basically takes in for each call that is each transaction, right? I'm going to using transaction and calls interchangeably, right? For each transaction that the user wants to carry out, right? The validate function basically takes in the contract address, takes in the entry point selector, and the call data. These are the three, if you check out, that's the three major fields in our call structure, right? And it is going to check, it's going to check that the signature for this particular transaction is valid. When you see the signature is valid, means that we're trying to check that the transaction was originated by a valid account by the valid account owner, right? So we're going to check that the signature is valid in this validate function. Finally, the execute function is what carries out the execution logic. So basically, in the execute function, we can do a whole lot of things. I think in here we can carry out functions like writing the logic for executing a multi-call. For example, as you can see inside here, the arguments I supplied here, we supply we supply a calls argument, right? Rather than just taking a contract address, entry point selector, a call data. So the whole idea was, although we are not going to we may not have enough time to implement a multi-call, right? But in the case you want to implement a multi-call, we'll go through a multi-call account contract, which are already implemented, right? You can simply swap out the logic we have in here and look through the calls, aggregating them before calling the call contract syscall. So, but in here, well, basically what we do is we take the call, and if it is a single call, we are going to just take out that single call and pass it on to the call contract syscall. But if it's multiple calls, right, we are probably going to run like a loop with a match statement, right, and try to aggregate these calls, and finally before calling the call contract syscall. So that's exactly what these functions do. So we're going to the validate deploy function basically is just still going to call the internal validate transaction function, which we already implemented, right? Then we're going to have the validate function, which is still going to do the same thing. We're going to call the validate transaction function, right? we're simply just checking that these transactions are valid. But things begin to get interesting in the execute function. So this execute function is where we're going to write some interesting codes, right? So first of all, I would want us to get okay. So the first thing I would want us to get, all things I think we need, right? Let's get the transaction info, right? Let's get the transaction info using the get transaction info, right? And we're going to unbox this, Louise. Okay, I'm going to unbox this. And next one, I would want us to check the transaction version, right? To ensure the transaction version is valid. So to do that, we're going to say let's just say let transaction version, right, be equal to transaction info dot version, right? And we're going to assert that the transaction version is not equal to 0. We're going to have issues in my Lang server again. Okay, so if it is equal to 0, I want to show an error that says invalid transaction version, right? Invalid transaction version. Okay. Something I want us to check again is we would want to check that the caller is a zero address, right? Unless we want to assume that there's probably foul play and through invalid caller error, right? So we're just going to we're going to say let caller be equal to the get caller address, right? And we want to check, we're going to check, right, that the caller is from the zero address, okay? And if not, we're going to just throw an invalid caller. All right, so I'm going to come here and then I'm going to use the variable which enables the zero to be available for use, right? The zero method to be available for use. So we're checking the caller is 0 and we're going to throw an invalid caller if it is not, right? Having done all this, right, we can now go ahead and we're going to get our call from this so the first thing I want us to do, right, is because like I said earlier, we're not building a multi-call contract. We're just simply going to check that calls contain just one um call contain just one element, right? And if not, we're going to see multi-call not supported to avoid bugs, right? Then over here, we're going to deserialize our call. We're going to come here and we're going to say to selector and the call data, right? And then we're going to say that should be equal to calls dot upfront, and we are going to unwrap whatever we get. Okay. So to use the unwrap method, to make the unwrap method available, we'll probably need to import the option treats, right? Yeah, the option treats. Okay. Yep. So coming over here, we're going to go ahead to write next. We're going to use the call contract syscall. Is that imported? Yeah, we already imported that, right? So the call contract syscall, basically, we're going to pass. It takes in an address. Let's just make things better. Address to be 2, and it takes in an entry point selector, right? That's how it. I think entry point. Remember, try this. No, I think it's the other way around. Entry point selector, which is going to be the selector. Okay. And finally, it's going to take in the call data. Now, the call data, we're going to change it to span. So, to make this a span. And basically, whatever we get from here, right, we want to unwrap the syscall. Use the unwrap syscall method on it. And because there's no comma, colon, semicolon, right, we'll probably return whatever we get. And just to ensure we get the raw output, we're going to use the raw output macro. All right. So basically, this should let's check if this compiles before we go ahead to take questions because we're already running out of time. I'm just going to go in here and run Scarb build, right? Okay, we have a few errors. So the first is type not found calls. Yes, that's an error on my end. So we're going to come here and this is supposed to be call, not calls, right? And the second error says the two identifier is not found. Okay, the two identifier is not found. The selector is not found. The call. Okay, I think that should. Yeah,
I think maybe
and I
you need
was
to import it from use or something.
okay. Okay, I don't get. Let me come in. Let me change this to entry points.
Ah, okay.
Select or.
The,
Uh,
uh,
okay, yeah. Let me try this again. Scabule. Yep, I think that was where the error from. So basically, that give me please, you know, yeah. So basically, that's an implementation of a simple contract on Starknet, right? So just to go over what we did again, right? We imported some certain methods, right? We created a call struct. And like I said earlier, this can be optional. We could probably just pass in if we want, because our account doesn't implement in multi-code, right? We could just go ahead and instead of what we did here, right? We could just pass in the contract address, the entry point selector, and the call data directly, right? And just pass that directly into the call contract syscall. But we did this because doing this way, right, makes it easier to probably swap our logic for a multi-core logic. Now let's look at how we could implement a multi-core logic. So because of time, I would probably not write the code from scratch, right? But I'm just going to go into an implementation I made, right, which you could probably check out later. And we're going to implement. We are going to just explain the codes, right? So if you go into the multi-call section of this repo, you could see here that this is exactly same codes, right, as what we have in our simple account, right? But where the difference is, as you can see here, when we got here, rather than just making a simple call to the call contract syscall, we pass our execution, our logic, right, into an internal function called execute multi-call. And let's see what this execute multi-call function does. So if you come down here, you can see the execute multi-call internal function is what contains the multi-call logic, right? And what we basically do is we get basically we specify a result, right? This is an empty array. We're going to populate this with the result of our calls. Then we go forward to make our calls arguments, right? The calls we are getting, right? We go forward to make it a mutable value because we want to do some manipulations on it, right? So we go ahead to make it a mutable value. Then we loop through it, right? We loop through the calls value, and while we loop, right, we pop an element. So basically, what the pop front method does, right, when you call a pop front on an array, it removes the first element from that array. So what we are basically doing here is we are removing the first element from the calls array. And when we remove the first element, we want to check that that first element indeed contains some call, and if it does contain some call, we are going to make a call to the call contract syscall. And as you can see here, even within the call contract syscall, we still use a match expression, right? To check results okay, right? Checks if the return data doesn't throw an error. So if it doesn't throw an error, right, what we simply do is we get the result and um, append we append the return data, right, to that result array which we created earlier. So the empty results array we created earlier, we're going to add, so the append, unlike the pop front, where the pop front removes, the append adds a new element to immutable array, right? So we're going to append the return data to the result. We're going to populate, like I said earlier, we're going to be populating this result with the return data from um, our function, right? So, but if it shows an error, right, we're going to simply panic. We're going to simply panic. So the panic with 250 just throws the panic saying multi-call field, right? And we continue. So once there's always a call, right? So this option none will not be called till we get to the last element of the array. So once we pop out the last element of the array, right, there will be no longer element, there will be no element anymore in the calls array. So we are going to, once the none basically is what detects that there's no element anymore in the calls array, and it automatically breaks the loop. And as you can see here, we then return the result with our populated. By now, the result has been populated with the return data from our calls, right? So we just simply return that result. And what we can see here, you don't necessarily need to know this by heart, right? This is just a temporary fix till probably the span serialize is added to the call lib. So you can probably just copy and paste this. You don't need to exactly understand what's going on there since we don't have enough time to explain that. So there's also a multi-sig implementation. There's a multi-sig implementation. So as you can see here, as always, we start with specifying the account contract module, right? Then we specify a module, so the account contract macro, then we specify a module called multi-sig. We go ahead to import some certain libraries we are going to be using for the contract. And just like we did earlier, we're going to create a call struct. And as you can see here, the multi-sig is a bit more complicated than both the normal and the multi-call contract. So as you can see, we have some certain storage variables. We have the num owners, we have the threshold, we have the previous transaction, the ownership. So the num owners, let's just summarize this, right? The num owners basically save the number of owners in the multi-sig. The threshold is the number of owners that must approve a transaction, right? That must confirm a transaction before it can be executed. Then the previous transaction basically stores the idea of the last transaction that was submitted to the multi-sig. Then we have the ownership. The ownership basically tracks the ownership of the multi-sig. So as you can see here, it's just the legacy map of the contract address of the owner to the bool. So we have another storage variable, which is a mapping of the owner's address to his public key. Then we have transaction info. So the transaction info is basically what tracks each transaction, right? It's a mapping of the transaction ID to the call structure. The call structure, as you can see here, contains certain information about the call. For example, the two is the target contract address, the selector is the target function, right? The call data is the call data being passed in. Then we added um, two new stuffs, right? We added confirmations, which returns the number of confirmations that have been confirmed for that particular transaction. And we added executed, which is a Boolean value that returns whether or not a transaction has been executed. So as you can see here, we have some certain events that are emitted. So submitted transaction is emitted this time a new transaction is submitted. We have confirmed transaction, which is emitted each time a transaction is confirmed. And we have executed transaction, which is emitted each time the transaction is executed. And in all these cases, what we just emit is the owner, that's the contract address of whosoever made the call to that transaction, and the transaction index, that's the ID of the transaction being operated on. Then in our constructor, we do something very basic, right? So we take in an array of owners. So the array of owners is the array of the multi-sig owners, and the threshold is the number of persons who would want to confirm a transaction before it is executed, right? And then we check that the multi-sig has a minimum of two owners. So we do not want a multi-sig basically supposed to have multiple owners. So we can't have a multi-sig with just one owner. So we want to check that the multi-sig has a minimum of two owners. Then we go ahead to check that the threshold is less than or equal to number of owners. Because it only makes sense. For example, I have a multi-sig of four owners, and I want to make sure that my threshold should be three. Because I can't, it doesn't make sense that I have a multi-sig of four owners and I'm having basically a threshold of five. We can't we would not be able to have a valid transaction in that case, because you can't have five persons approving a transaction when there are just four owners, right? So next up, we store the number of owners, right, in case to be available in case anybody want to make a call to it. Then we store our threshold, and finally we dedicate the logic to an internal function called setOwners. So let's just code down to see what our setOwners does. So the set owners, where is that? 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 Yeah. So this is set owners internal function. Basically, it's a function that sets the multi-sig owners on deployment. So basically, we get the multi-sig owners, we get the array into immutable variable because we want to perform some operations on it, right? Then we loop through it, and each time we pop an owner. When we pop an owner, if there's an owner using the option sum, right? If there's an owner, we simply write it to the storage variable, and when there's none, we just simply break. That's what the set owners basically is what adds the owners to the mapping. The mapping we have here as the ownership mapping. All right. So next up, we have the get confirmation. So the get confirmations basically returns the number of confirmations for any transaction index to supply. So if we want to check how many persons has confirmed a transaction, we can simply call the get confirmations with the transaction index. And we have the get num owners, right, which basically returns the number of owners in our multi-sig. Then get owner pub key can be used to return the public key of any owner in our multi-sig, right? Then there's a function to set a public key. So this is the compulsory function, something that must be done for every owner in the multi-sig, right? Then the first interesting function I want us to look at is submit transaction. So basically, what does the submit transaction do? So it takes in the contract address, the entry point selector, and the call data for that particular transaction. And as you can see, we get the caller address. And the first thing we want to check is that we want to check that whosoever that is calling this function, right, is a valid owner, right, is a member of the multi-sig. So that's an internal function is owner. So you can see here it checks the ownership value of that particular address. So if it's true, then we can proceed. If it is a false value, then we assume that that user is not a member of the multi-sig. So next up, I think the second thing we do check is whether the user sets the public key. Like I said, this is a compulsory function for every user in a multi-sig, right? So this is the internal function that handles that. It just simply checks if an owner set his public key. If it returns a zero, then if it returns a zero, then we assume that the owner hasn't set his public key, and we ask him to set his public key first, right? So next up, we proceed to creating our call. So we populate our call structs with the selector and the rest, right? So we create a call using whatever we got from here, right? And finally, we're going to get the previous transaction ID. We're going to get the previous transaction ID and then create our new transaction ID. So our previous transaction ID is stored in the previous transaction storage variable. So when we read that, we're going to add one to it and it will become our new transaction ID, right? Then we come here and we're going to store call in transaction info. So basically, I'm going to create. Remember, the transaction info is what tracks the transaction ID and the call information, right? The um the content of the transaction which is stored in the call, right? So I'm going to write that to this transaction info mapping. And finally, we're going to update our previous transaction to a new transaction ID, as you can see here. And once we do that, we are going to emit the submitted transaction, which is an event that is supposed to be emitted each time a transaction is submitted with the caller and the transaction ID. Then we have the confirm transaction. The confirm transaction function basically takes in the transaction index for a transaction. As always, it gets the caller address, it performs some check. It checks that the caller is a valid owner, it checks that the transaction exists, it checks that the caller sets the public key and he hasn't confirmed before. And finally, yeah, that he hasn't confirmed before, right? This is a very important function, right? We do not want one person confirming multiple times. That would be a huge loophole in our multi-sig contracts, right? So we have to implement a check for that. Then next up, we get and we deserialize the call. As you can see here, we get the transaction info and we deserialize it into this. Next up, we are going to update the number of confirmations by one, right? So if the confirmations currently is zero, right, we want to increase it by one and then update the call. So we're going to create a new call, updated call, a new updated custom data structure, right? The custom structure has the updated call using the call structure, right? And once we do that, we are going to write the updated call to the transaction info. And finally, we are going to confirm that we're going to update the has confirmed with the caller and the transaction index to true. So if you check the has confirmed, basically, we have confirmed is a legacy mapping of the contract address to a FL 252, which is basically the transaction ID. That this is a tuple, right, to the bool value, which should be true or false. So in this case, we update it to let well everybody know that right this particular owner has confirmed this transaction. Then finally we go ahead to emit confirm transaction. That's the confirm transaction event. Then as you can see, the validate declare, validate deploys are all these are just functions that we've talked about. Basically, they do not do so much. They do not implement a logic so different from what we have previously, right? So the next, I think should be the last important function I want us to look at, right? Is the execute function. So the execute function is basically what executes function in our multi-sig, right? So basically, we want to first of all check a transaction exists. That's the first thing. Once we check the transaction exists, right? We go ahead to get deserialize the call. We're going to get the call for this particular index. When we read it, the information, right, to get the true selector and call data. So now, this is very important, right? We want to check that the number of confirmations for these particular transactions is greater than or equal to the threshold. So if the threshold is 3 out of 4, we want to assume that at least three persons had confirmed the transaction. If not, we're going to throw an error that says the minimum threshold has not been attained yet. So next up, we are going to make contract call using the low level call contract call, right? As you can see here, we saw this in our simple contract, right? So we're just going to make a call to this, passing in the address, the entry point selector, and the call data. And finally, this is going to return the data, right? Then next up, we're going to want to update our transaction status. So as you can see, we have executed in our transaction status to track if the transaction has been executed or not, right? So in the beginning, this is going to be false, right? So we want to update it to true. As you can see here, we're going to update it to true. Then finally, we're going to write that new info to our transaction info. And finally, we're going to emit the executed transaction and return whatever was data gotten from executing that transaction. Now, it's worthy to note that this particular multi-sig function does not support multi-calls. But like I said earlier, if you understand the multi-call account implementation, right? We would simply just need to swap the logic, this logic, right? Sorry, this logic that calls for a single call, right? And simply just run a loop to loop through the multiple calls and aggregate them into one. So that should not be very difficult to implement. You could probably try it out later in your free time. And I'm very sorry, we're rushing through this, right? It's just we are very much out of time. So I don't know if there are any questions before we probably proceed to um,
Yeah,
other things.
there are
Yeah.
there are a few questions on the YouTube live. I'm just gonna run them through very fast, and we'll try to close it in the next 1 or 2 minutes. There is one question by an anonymous user about, I think, earlier slides that you had shown. Can you describe a bit more about nonce and why it may fail check? I think this is from the earlier slides, so I'm going to skip this and maybe move to the contract related one. If we return not validated but something different, for example, message, will the transaction fail the check? So I don't know if you are able to see this, but I sent you this question on Telegram as well. Um, and I also sent you the YouTube live link where you can. So maybe what we can do is, just in the interest of time, Darlington, you have access to this YouTube live link, and you have access to all the questions that folks have asked. So maybe you could just answer, in the comments. Does that
Okay,
sound good?
sure. Okay, you mean probably after the
Yes,
call, right?
yes,
I could probably scroll
yeah,
through the comments and
yeah,
probably answer. Sure, no problem. That
yeah.
that would
Because
work
we are
because we
already
are way out of time.
yeah, because we are already 14 minutes over, and I just want to make sure that I respect your time and everyone else's as well. So, yeah. And yeah, just on a closing note, thank you so much, Darlington, for joining us. I know you shared the slides as well, so maybe if you can share the link to the slides if it is open source on the YouTube channel link, I mean, over there as a comment, that would be helpful. And last but not the least, just like one of our users who commented on the YouTube live, this was a dope session. It was super awesome. We all learned a lot. And for those of you who asked if the recording will be available, yes, it will be available on YouTube as it is being live streamed. So you can always go back, check out the contracts. And once Darlington shares his slides as well, there are GitHub repo links that you can go to, look at the contracts, and feel free to ask questions in the Starknet, different groups, whichever groups you're a part of, whether you're part of the Africa group, whether you're part of the India group, whether you're part of the North America group, or just the ecosystem group. Feel free to ask questions. You can also come back and ask questions um, on this YouTube channel as well, and we'll hope we can monitor that and get your questions answered. Is there anything that you want to share, Darlington? Any other information that you would like to share with folks?
Not really, we are out of time, but okay. I think I promised to share some interesting use cases we've been working on. Probably if you still have 1 or 2 minutes to spare, maybe we could
Okay,
do that.
okay, yeah, sure,
Yeah, yeah.
sure, sure, yeah, why not?
Okay. Could you help me add the slides back to the screen?
Uh,
So,
yeah, slides. Yeah, this one.
yeah. So yeah. So basically the account abstraction use cases, right? So I talked about social recovery, right? I explained how I looked at this to my life savings in 2021 just because I had forgotten my seed phrases, right? So for example, if you use a social wallet like an account abstraction wallet like Argent, right? We have something called social recovery implemented, which enables you to add guardians to your wallet. So basically, you could add another wallet. You could add the hardware wallet. You could add friends and family as guardians, and in case you get locked out of your wallet for any reason, right, you could probably hit up a guardian, and they would help you get access back into your wallet. So we have Agent Shield, right, which can help you protect your account with a two-factor authentication using an email address, right? Basically giving you that Web2 UX experience in with the touch of Web3, right? And we also have multi-call, which I explained earlier, which you could see in EMMs and NFT marketplaces like Aspect. And we are working on sessions, right? Together with the influence team, which would enable you carry out if you play games right on blockchains, they can really be very annoying with the whole signing stuffs within games, right? So basically, with session keys, you could basically just sign once and just play your game without interruptions, right? And I think that's about it. So basically, the whole idea of account abstraction, right, is combining Web3 magic with the Web2 user experience. And I think that's about it. Thank you so much for the opportunity to be here, and I hope we learned a whole new lot. So let's just build a new Web3 UX together. Thank you.
Of course. Thank you so much. Thank you, Darlington, for your time. We really, really appreciate it. And I hope that all of you are able to, be just watch this workshop again, look at the contracts, write your own contracts. If you write your own account contracts by following this workshop, and you're able to successfully deploy it, build it, and deploy it, please tag Darlington and Starknet on Twitter. Please take a screenshot and tag us, and we'll be happy to retweet your successful deployment contracts. And thank you so much once again, Darlington. I hope to see all of you at our next community call slash workshop call. Thank you, everyone. See you.
Yeah, thanks so much, Gian. Yeah, bye.